Because you don't have the traditional means of communicating with your embedded device as you would, say, a laptop or a mobile phone, well, you have to be very specific about how you send information in and get information out. The way that you do that on these embedded devices is through something we call the pins. The pins are the physical access points on your board that take in information and send it to the processor, and then take information from the processor and produce it back out. These are where you're going to hook up all of your circuits. If we look at the Raspberry Pi 3 board, you can see a bunch of metal prongs all aligned in a series of rows. These are your input-output pins, and each has a specific function. In order to know what each pin does, you have to be able to read what we would call a pin diagram. They are traditionally laid out in the same physical orientation as the pins and then tell you what each pin can do. Some of the pins have very specific functions, so you can't just hook up your devices to any single one of the prongs. You have to make sure that you're paying attention to your maps. Here's what a pin diagram might look like for the Raspberry Pi 3. As you can see, it's laid out like the pins are and indicates which pin does what function. Make sure that you're always looking at your pin diagram in the correct orientation, because simply flipping it can cause real havoc on your circuits. Let's talk about some of the types of pins on the Raspberry Pi 3. While this is specific to the Raspberry Pi 3, these types of pins exist on almost all embedded devices, at least these categories. They'll probably just be in a different orientation. There might be a different number of them. For example, the Raspberry Pi 3 offers two different voltage sources. You can either issue a 3.3 volt power or a 5 volt power. So let's say you have a peripheral that needs to be powered, like an LCD screen or a motor. Well, you can hook it up to these pins in order to produce power to your circuit. There's also a bunch of pins called ground. Remember that your circuit has to be a perfect circle, so you'll always want to make sure that you connect your pins, sending out all of your information and then coming back to a ground so you get that nice circle. Then we have what we would call the GPIOs, or general purpose input-output pins. These are just ways for you to send electrical signals representing information both in and out of your device. So you could say send a signal to turn an LED on, to modulate a motor, to take in information from a sensor. That's why there's so many of these pins, because they're there for you to use however you would like to use them. Then there's a series of pins that are specifically set up for communication protocols. Based on which sensors you purchase, they might have specific limitations for how they communicate with your processor. For example, maybe they use the I2C communication protocol or the SPI, or are serial-based. Just make sure that before you hook anything up, you check how it needs to be communicated with and you use the appropriate pins. Learning to read a pin diagram can be a little daunting at first, but it's pretty easy once you get the hang of it and make sure that you're holding your diagram in the correct orientation. You just have to start thinking about your data in much smaller chunks, in a single signal coming in and out of the metal prong. But once you start building a few circuits, it's easy to get the hang of.